So अभी हम देखने वाले हैं प्रॉब्लम 40 गेट फिजिक्स 2025 and what we are asked. So we are given a thin circular ring of radius r which lies in the xy plane with its center coinciding with the origin. Fine. A ring carries a uniform linear charge density lambda. The quadruple contribution to the electrostatic potential at the point 0 d where d is greater than r. Okay. So it's a very simple problem to observe because so हम लोग को पहले क्या निकालना है कि इलेक्ट्रोस्टैटिक पोटेंशियल एट अ पॉइंट फार फ्रॉम द चार्ज डिस्ट्रीब्यूशन का एक्सपेंशन क्या होता है इन टर्म्स ऑफ मल्टीपोल मोमेंट्स. ओके सो वेट अ मिनट. राइट. ओके नाउ द इलेक्ट्रोस्टैटिक पोटेंशियल V at a point far from a charge distribution. We can already have a hint towards it, the point being far, because we are given d greater than r. R is given to be the radius of the thin circular ring, right? So from a charge distribution can be expanded in terms of multipole moments, as Vr is equals to 1 upon 4 pi epsilon naught times q over r plus p dot r cap over r square plus half qij ri cap rj cap, the unit displacement vectors in the direction of I and j, r cube and so on. We can stop this expansion at this point because हम लोग को quadruple जानना है और quadruple moment का tensor quantity जो है वो है qij. Okay, so what is q? Q is the total charge. Okay, and this is the monotone term. Okay, p is the dipole moment and qij is the quadruple moment tensor. Fine. Okay, so what we are given is that what is the quadruple contribution. To get hold of the quadruple contribution, we need to check first what is the monopole and the dipole contributions. Okay, so this is the monopole contribution, this is the dipole contribution, this is the quadruple contribution. Okay, so let me just hint towards them once. Okay, fine. So this is the dipole contribution and this is the quadruple contribution. Okay, these are the three contributions which we need to get hold of. Fine. Okay, now so what is the monopole contribution? Let us first check what is the monopole contribution. Okay, now total charge is q, and so q is basically lambda times 2 pi r because lambda is the linear charge density and the circumference is 2 pi r. Fine. But the potential due to this monopole, charge falls as 1 by d, right? Therefore it does not contribute at all to the quadruple term. So there is no contribution due to the monopole term to the quadruple term, right? So we are fine with it. Now we need to check whether the dipole contribution adds anything to the quadruple term or not. So what is the dipole moment? So the dipole moment is basically P is equals to integration of r prime sigma r prime dA. Fine. But the ring has uniform charge density, right? This ring has uniform charge density, right? Furthermore, it is symmetrically distributed around the origin. Also, the charge is symmetrically distributed around origin. Therefore, the net dipole moment is 0. Therefore, the net dipole moment is 0. Hence, no contribution. So, this also doesn't add to any contribution, right? So, we are done with the monopole term. We are done with the dipole term. And hence, the only thing which we need to calculate furthermore is what is the contribution by the quadrupole term. And that is exactly what we are asked here, right? Okay. Fine. Now, the quadrupole moment tensor, which is given to us, the quadrupole moment tensor for a ring of charge is basically, so it is denoted as QCZ is equals to lambda times 2 pi r square over 2, right, which is equals to pi lambda r cube, right? Therefore, the quadrupole potential term is, so it is given as V quad, it is denoted as V quad, and this is given as 1 upon 4 pi epsilon naught QZZ upon 2d cube 3 cos squared theta minus 1. So what should it come out to be? So let us keep this formula for now because we need to evolve out the parameters of theta. Okay, but the parameter of theta is very easy to solve, right? Because since the we are evaluating at the point 0,0d, therefore theta must be equals to 0, right? You can easily observe it out. Therefore, my 3 cos square theta minus 1 is just 2 because cos at 0 is 1, right? Therefore, my V quad is coming out to be 1 upon 4 pi epsilon naught. QZZ was pi lambda r cube. Here is 2d cube and here is 2, right? So therefore, this is coming out to be lambda r cube by 2 epsilon naught d cube, right? But the quadruple potential has a sign of negative. That is something which you require, okay? Stability, or rather stabilizes. Okay, so your answer should be minus lambda r cube over, am I doing anything wrong? Wait a minute. Yeah, so let me get back to the problem. Yeah, so it should come out to be, yeah, so what is the, what were the options? Okay, let me just go back once. Get the options. Yeah, so minus lambda r cube. Yeah, so option A should be your correct answer, right? So option A should be your correct answer. Got it? Fine. Right, so our calculation is correct, right? So I have a 2 there. These 2 and these 2 cancel out, right? These 2 and these 2 cancel out. The pi and pi cancel out. Okay, so I think I have written a, okay, right? So this should be 4. Fine. So minus 4, and then you should have epsilon naught d cube. Yeah, so this should be your correct answer. I did a calculation mistake, I guess. Yeah, so option A is the correct answer.